Now we're going to take a look at how do I go the other way. So if I'm given rectangular form, if I'm given x and y, how do I write it in terms of r and theta? All right, so obviously they're going to come up with some formulas that we're going to be using. All right, so again, graph 1, 1. All right, so we're going to go ahead and graph 1, 1. So let's say 1 is here and 1 is here. So the point 1, 1 is right there, okay? What is the x value? 1. What is the y value? 1. Okay, that was relatively easy. All right, using Pythagoras theorem, find the radius. Okay, so this is the radius right here. All right, let's write the formulas that we're going to be using for this question each time. So using Pythagoras theorem, how would I write r? So we're going to label this x and label this y. So r in terms of x and y would be, so this is opposite, this is hypotenuse, this is adjacent. All right, so using Pythagorean theorem, we have x squared plus y squared equals r squared, or r squared equals x squared plus y squared. Okay, so how do I find r? I take the square root of both sides. So this is the square root of x squared plus y squared. So go ahead and highlight that because that's going to be a formula that we're going to use a lot. All right, going on to this one. If I had to write out tan, so tan is O over A, so y over x. And then theta is the inverse, remember, right, inverse like that of y over x. Okay. All right, so once you have, these are the two formulas that we're going to use because now I'm going from x and y to r and theta. So I'm going from x and y to r and theta. All right, so let's do the math for this question. So you have the point 1, 1, so this is x and that's y, right? R is the square root of x squared, which is 1 squared, plus y squared, which is also 1 squared. So r is equal to 1 squared plus 1 squared is 1 squared is 1 plus 1 is 2, square root of 2. All right, tan is y over x, so y is 1, x is also 1, so this is equal to 1. So where on the unit circle do you have both x and y the same? Okay, and those are the same at 45 degrees or 2, 3, 4. Pi over 4 or 45 degrees. You're going to get what? Radical 2 over 2 comma radical 2 over 2. When both x and y are the same, when you divide them, you're going to get 1. Okay, so if I evaluate theta at that point going backwards, radical 2 over 2 divided by radical 2 over 2 gives me 1. So that means I'm looking for pi over 4, 45 degrees. It means that theta is equal to pi over 4. All right, or you can just put in the calculator and do inverse tan of 1, and you're going to find that it's pi over 4 or 45 degrees. Therefore, writing out my r first, so r is going to be radical 2, and my theta is pi over 4. So I just converted rectangular or Cartesian coordinates into polar form. All right, let's do one more. Let me do one more, and then you guys can do one. All right, so let's example 5. Convert the rectangular coordinates, so this is x, this is y, into polar. Express the angle using radians in terms of pi over the interval 0 to 2 pi. In other words, don't make it bigger than 360 with a positive r value of r. Okay, cool. Let's go ahead and get started. So r is equal to the square root of x squared, so this is 9 squared, plus y squared, plus this squared, all right, and you're just going to put the whole thing in the calculator. So radical, we have 9 squared plus negative 3, radical 3. Oh, and be careful when you're doing this to make sure you're, coming out of the square root there, squared. So 6. So this is going to be 6 radical 3. So that's r. Now we're going to find theta. So to find theta, it's going to be the inverse tan of y, which is this, negative 3 radical 3, over x, which is 9. And because these are not numbers I recognize, I'm just going to put it straight in the calculator. So inverse tan, so you can see tan is right here. Inverse tan is in green, so that means you hit the green one and then that. So inverse tan of, I need a fraction, so I'm going to put ND. And then on the top, negative 3 radical 3. And on the bottom, 9 come back out, close the parentheses, boom. So that's going to be negative 30. And how do I write negative 30 in radians? They usually want the answer in radians. So negative 30 from the unit circle, once again, is right here. This is 30 degrees. So we're going to make this line so a little bit off there like that. All right, so negative 30 is going this way. So this goes 2, 3, 4, skip 5, 6. So this is pi over 6. All right, I want to go negative. So I want to go over here. All right, so what's this one? Writing it in terms of a positive value. All right, so to get here, I'm going to go all the way around like this to be positive. And to get into this quadrant, it's $5 at 7-11. So this is 11 pi over 6. So 11 pi over 6. All right, it's the same thing as writing negative 30. And I'll prove it to you in the calculator real quick. So 11, so ND, 11 pi. Give me a second. Where's pi? 11 pi over 6 is equal, oh, this one doesn't do it. Put it in delta math then. It should do it for you. All right, so write this in terms of the coordinates r first. So 6 radical 3, comma, 11 pi over 6. So positive r value, and oh, it didn't tell us to necessarily write this in positive, so you could actually write it as also negative pi over 6 instead of writing it as positive 11 pi over 6. All right, but go ahead and do example 6. Let's practice.